So in sequences 3, this continues our work from looking at linear sequences and looking at finding the nth term and finding terms using the nth term, where we'll be focusing on looking at patterns and typical exam style questions related to linear sequences that you may get in a test, in a homework or in an exam. This video continues from linear sequences and finding the nth term, so this is definitely a follow on, so if you've not watched those videos, I'd recommend you watch those just to get an understanding of what the nth term is and how we substitute numbers into a formula. So this is kind of an extension following on from that, looking at patterns. Now this tends to appear more in sort of exam style questions, and it's important that you move your knowledge on from working with basic list of numbers to these types of problems. So let's go straight into it. So here we have a sort of a pattern involving sticks and squares, and in the question it's asking us to draw the fifth pattern, find the nth term, so sticks to pattern number, which is really important that you understand what type of nth term we're looking at in this particular case, and find the number of sticks in pattern 20. Now these are the general structure of what most questions ask for, however they're not going to be fixed and may ask for other things which hopefully we'll bring up in this video. So the first thing, let's get started, is to draw the fifth pattern. Now this one should be relatively simple for you, so if I just colour this in red so we know which one we're doing. So for A, all I'm doing is drawing out a pattern so that I've got 5 squares. So this is going to be pattern number 1, pattern number 2, pattern number 3, pattern number 4 and pattern number 5. Now the good thing to note in this, and this probably leads into the next part, is the pattern number is also the number of squares in your pattern. So the number in which it falls, so this is pattern number 1 and we've got 1 square, pattern number 2 has got 2 squares, pattern number 3 has got 3 squares, etc. So if you're drawing pattern number 7, then I don't need to draw pattern number 6 first, I can go straight into drawing that, and if I want to draw pattern number 12 I can just draw that without having to draw any of the previous patterns together, which just comes in handy when you use your common sense to work that out. So moving on to the next one, so to find the nth term of this pattern, sticks to the pattern number. So this is basically what we're starting with, and the number of sticks is what we want to finish with. And that's really important. Now, if pattern was replaced with squares, then that can be easily done, but usually 1 would start in consecutive numbers, so 1 would start with 1, 2, 3, 4, 5, 6, and the squares might be slightly different. Again, hopefully that will come up in a sort of another example that we do. So the first thing you want to do with regards to find the nth term, or the relationship between the pattern number and the number of sticks, is first of all draw a table. So if we have pattern number, I've got the end there, and we have the number of sticks. So just extending this further, so far I've got, generally speaking, when you get comfortable with these, you don't have to draw a table or sort of cells for every pattern that you've got available to you. It kind of comes into question, so let's just use a different colour so it stands out a little bit more. So we've got pattern number 1 has got 4 sticks, pattern number 2 has got 7, pattern number 3 has got 3, 6, has got 10. Now as you can see slowly, that just by filling in this grid, that we're slowly noticing that the numbers are going up by 3, because obviously counting the number of sticks depending on the pattern can be very time consuming, so spotting these types of niche little things can make your life a whole lot easier. And then we've got 16, and also it's just worth just double checking to make sure that I've not gone a bit cocky and kind of guessed what and assumed something that's not actually true. So if I just count the pattern number 4, so I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, so it's correct. Now, I haven't answered the question, but if you've watched the previous video, here we've got, and I don't know why I've got a 15 there, so let's just get rid of that there. That's pattern number 5. So what we want to do is take these numbers out of the table. So if you imagine from our last video, what we had was just a string of numbers, so I've had 4, 7, 10, 13, and 16. So the first thing I want to do is establish what the difference is between these numbers. So you can see here that I've got a difference of +3, which means that 3n is going to be in the formula, and then once I've got the difference, I then relate that to the very first number, which is 4, and what I have to do to get from 3 to 4 is basically add 1. So our nth term formula is 3n plus 1. Now because this relates to a pattern, so here I've got that the numbers in the sequence, or the term in the sequence, or the value of the term in the sequence I should say, is 3n plus 1. Now in this we're not talking about numbers in a sequence, we're talking about patterns. So here, right, I'm going to replace sequence for sticks, and I've got 3 times the pattern number plus 1 equals the number of sticks. So what I'm going to do instead is I'm going to say S is equal to 3. Now I'm still going to use the word n plus 1, and that's how we can find the number of sticks in any given pattern. Now one thing you might want to do is, as you can see and as we talked about, is the pattern number is also the number of squares. Now obviously sticks and squares, a bit of a mouthful there, begin with the same letter, so you don't really want to have a formula or an expression that involves the same letter. So I could have generally a capital S that represents sticks. I also don't want to have 2 letters, so I don't want to write ST because that might look then like S times T. So try and avoid that. So here generally go for n. So here we've got, if we wanted squares, so if n represents the squares, the formula would be exactly the same. And then finally for C, so again if I just use a different colour for that. So for C, all I want to do is replace n with the value of 20. So then what I've got is I've got 3 times 20 plus 1, and that equals 61. So there's going to be 61 sticks in pattern number 20. Now again, a question could ask you is, how many sticks would there be for there to be 20 squares? Well again, I could just swap n for s, for square, sorry, because the pattern number is the same as the number of the pattern number, and I just need to substitute 20 in for that. So let's have a look at another question, or another pattern I should say. So here again we're asking to draw the 5th pattern, and we're drawing find the nth term, or the formula that links pattern number to sticks, and to find the number of sticks in pattern number 20. So in this one we don't really have pattern number 4, so I'm just going to have to assume what that is. But as I can see, using my common sense, using my eyes, I can see that although this is pattern number 1, pattern number 2, pattern number 3, that the pattern number refers to how many squares I can see and how many triangles there are. So if I'm drawing pattern number 5, I know that there's going to be 5 squares, and there's also going to be 5 triangles. Now when it comes to exams, you may be questioning why am I not using a ruler, because your teacher would always say use a pencil and a ruler. And also, does it matter if the lines or the sticks are joining together? Well, not really. As long as you've got the general shape, it should be good enough for you to get the marks. As long as it resembles the original pattern, you're going to be absolutely fine. So for B, again, which I'm going to use in a different colour, so again we're going to set up our table. So I've got the pattern number, which I'm just going to call n. So I've got 1, 2, 3, and I'm going to 4, which we've not got, but 5 I have got, and I've got S, which is the number of sticks. So in pattern number 1 I've got 6 sticks. For pattern number 2 I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. In pattern number, again let's just put these in grids. For pattern number 3 I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And so as you can see straight away that the numbers are going up in 5. So even though I haven't got pattern number 4, which I've not drawn, I can simply add 5 to 16, which I'm going to get 21, add 5 to that, I'm going to get 26. And again, if I want to make sure, which is always good if you've got time, is just count the number of sticks you've drawn in pattern number 5, and it should add up to 26. So now, again, we've not finished because we need to find the nth term. So again, I'm looking at the difference, which is 5. So I've got 5n. And then what do I need to do to get from 5 to 6? Well, I need to add 1. So then the nth term is 5n plus 1. Now again, because we're dealing with a pattern, we want to relate it to what this actually shows. So the number of sticks is equal to 5 times the pattern number, which we're going to call n, plus 1. And that there is our formula. Now again, make sure you're knowing the difference between my difference of my s's and your 5's, because at times they can look very, very similar. So moving on to question C. So again, with question C, all I've got to do is substitute n equals 20 into this formula. So I've got S equals 5 times 20 plus 1, which gives me an answer of 101 sticks. And there is your final answer. So moving on to example 3. So here you can see we've got a slightly variation to the pattern above, but we've got the same concept. So as you can see here that the pattern number, so if I just label this as pattern number 1, number 2, number 3. Now here the pattern number does not sort of relate to the number of triangles we can see. It's actually double that. But here we've got the number of squares. So if I'm asked to draw pattern number 5, and I'm going to end up with, let's just colour that so you know what I'm doing. So for A, I've got to draw 5 squares. And I'm going to draw a triangle on top of each of those. So again, here we're going to look at the nth term for the number of sticks for this one. Now what I'm going to do is I'm actually going to change this question slightly as an extension to see if we can link between the number of sticks, and we'll do one for the number of triangles that we've got here. So for B, again I'm going to set up my table. So I've got 1, 2, 3, 4, 5. And I've got S, which is the number of sticks. So counting the number of sticks in pattern number 1, I've got 4, 5, 6, 7, 8. For pattern number 2, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. For pattern number 3, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So looking at the difference between these numbers, you can see that I'm going up in sevens. So the next one's going to be 29 and the next one is going to be 36. And again, you can check to make sure that is correct. So again, using the numbers on the bottom row for the sticks, I've got a difference of 7, so I've got 7n. And then what do I need to get from 7 to 8? Well, I need to take away 1. So this is the nth term. So then for this, what we're looking at is that the number of sticks equals 7 times the pattern number, take away 1. Now again for C, all I need to do is substitute 20 into this formula. So I've got 7 times 20, take away 1, which is 139 sticks. Now as an extension, let's say we're looking at pattern number and we're looking at the number of triangles. So with pattern number 1, I've got 2 triangles. With pattern number 2, I've got 4 triangles. With pattern number 3, I've got 6 triangles. And pattern number 5, I've got 10 triangles. And looking at the difference between the numbers, with pattern number 4, I'm going to have 8 triangles. So again, I'm going to try a little in terms of this. So here we're looking at the pattern number and the number of triangles. So you could get a question that says, how many triangles would you expect to get in pattern number, I don't know, 105? In which then you haven't got the time or the space to physically draw pattern number 105 to then count the number of triangles. So you kind of got to use your common sense. Now as you can see here, that the difference is going up in 2. So I've got 2n, and I don't need to add anything or take away anything because 2 is the same as 2. So this is the formula. So the number of triangles is 2 times the pattern number. So if I want to know how many triangles, so how many triangles are in pattern, let's say 205, then all I need to do is substitute that in or double it, in which it would be 410 triangles. So it's really important you read the questions carefully, because it's not always going to be what you see. It might be related to the number of triangles. It might be a case of, well, if you know that there are 16 squares, how many triangles are there? Or if there were 20 triangles, how many squares would there be? Then you need to try and adapt your question and the tables and the numbers you're using to answer that particular question. So moving on from that, let's have a look at the next question. So here we've got another pattern. So again, if you want to have a go at these before I talk through it or ruin the question or produce a spoiler, then please do just pause the video and have a go at it before I go through it. So for here, we've got pattern number 1, 2 and 3. Now as you can see, it's difficult because the pattern number doesn't really resemble how many squares I can see. But one thing I do notice is that the pattern number is basically how many squares I've got on top of the top layer of this particular pattern. So for A, I'm going to end up with 5 squares at the top, which means I'm going to end up with 6 squares at the bottom. So there's my pattern number 5. So for B, again, I'm going to set up my table. So I've got 1, 2, 3, 4, 5. Why have I gone to 5? Well, again, it's just a case of being able to spot a pattern. And if you've watched quadratic sequences, which will be the next video, you'll notice that when you haven't got a sequence that's going up by the same number, then the formula is going to get a lot more complicated. So anyway, back to this. So in pattern number 1, we've got, so just count the sticks, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. For pattern number 2, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then I'm guessing that the pattern numbers are going up in 5s. So again, looking at the difference between the numbers, we're adding 5, so it's going to be 5n. Now what do I need to do to get from 5 to 10? Well, I need to add 5, so it's going to be 5n plus 5. So the number of sticks equals 5 times the pattern number plus 5, and there is our formula. And then for C, to work out pattern number 20, all they need to do is do 5 times 20 plus 5, which gives me 105 sticks. Now, as an extension for this, you might get a question where you're asked to work the complete opposite. So a question might ask you is how many, what pattern number could you make if you had, I don't know, 600 sticks? So if you had that type of question, in which, let me just go through an example of what that may seem like. So if I had a question that said what pattern number would, so let's just actually write this down. And there we go. So we'll just keep the formula just in our screen. So if a question asked you, so let's go for D, how many, what pattern I should say. So what pattern would have 70 sticks? Then all we need to do here is, ignore that, is simply replace S with 70. So I've got 5n plus 5 equals 70, and then all we then need to do is simply solve the equation. So here I'm going to take away 5, so I've got 5n equals 65, and then divide by 5, in which I end up with 13. So it's going to be pattern number 13 will involve 76. Now if a question asks you what pattern number could you get to if you had let's say 120 sticks, then all we need to do is turn it into an equation and we can go from there. So if I then had, let me just get rid of this question here. So if a question asked you, let's go for E, so what pattern number could you reach if you had, let's go for a crazy number, let's go for 613 sticks. So here what we're going to do is we're going to make our formula or nth term add up to 613. I'm going to take away 5, in which I'm going to get 608. So I've got 5n equals 608. Divide by 5, in which I get n equals, now this is going to give me a decimal answer, which is not a problem. So I've got 608 divided by 5 gives me 121.6. So basically I've got to round down on this because obviously I can't have 0.6 of a pattern number because the n has got to be a whole number. So then that rounded up is going to be 121. So basically I could make pattern number 121 if I had 613 sticks available. And again, they're kind of the latter parts of the question, so it's important that you're able to answer those questions as well. So let's have a look at this one here, which involves hexagons. So here we're looking at our fifth number. So again, using our common sense, because obviously we don't have pattern 4, so I can't just simply add on 1. But I noticed that the number of hexagons is the same as the pattern number. So again, just write number 1, number 2, number 3. So pattern number 5, now this is where my drawing skills might let me down. I think I've survived, so there we go. And then we need to draw our table for part B. So that's part A done. Part B is we've got n is our pattern number, so 1, 2, 3, 4, 5. We've got the number of sticks, or numbers in our sequence, which floats your boat. And now here, counting the numbers for number 1, we've got 6. For number 2, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then for pattern number 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And as you can see, I'm going up in 5s. So without counting the next one, I'm going to have 21 and then 26. So then looking at the nth term, the difference is 5, so I've got 5n. What I need to get from 5 to 6 is plus 1. So then the nth term or sequence, so the number of sticks of the pattern number is going to be s equals 5n plus 1, which I think is the one that we've already done before. But again, it's a different pattern. And like in an exam, you'll only get one of these questions, you won't get 6, so there won't be any duplicates in that. So the next thing we then need to do is answer the follow-on question from that, so where we use the nth term. So for C, we've got 5 times 20 plus 1 equals 101 sticks. And there we go. So moving on to an exam style question. So this doesn't involve a pattern number, but I've seen this in a more recent exam paper that one of my students did. And let's have a look at how we go about answering this. So in this it says that the fifth and the sixth term of a linear sequence is 34 and 38 respectively. Find the 102nd term in the sequence. Now, if it was asking for the 8th sequence or the 10th sequence, I might be able to, depending on how I start this question off, it might make things a little bit easier. Now, the difference with this, and a couple of key things you need to notice when you're reading this question, is here we're not given the start of the sequence, we're only given the 5th and the 6th number. So if I start this off, if I look as if I'm about to play hangman, so I've got 5, 6. So we know that the 5th number is 34, and this 5th number, the 6th number is 38. Now the next key word in this is linear sequence. So this means that the difference between each term is going to be the same, and that's really, really important. So looking at the difference between 5 and 6, that's going up in plus 4. So that means that the difference between each consecutive term is going to go up by plus 4. So to go in the opposite direction, all I need to do is take away 4. So 34 take away 4 is 30. That take away 4 is 26. That take away 4 is 22. And that take away 4 is 18. Because it's really important that when you're trying to find this, now in order to now find the 102nd term, what we need to do is we need to find the nth term. So kind of backtracking a little bit, and this is why it's really important. Now, in order for me to find the nth term, to make my life a little bit easier, I need to know what the first term is. And here I've got my 18 as my first term. Now, because the difference is plus 4, I know that 4n is going to be in the formula. But without knowing the first term, I can't do this step where I'm thinking, okay, what do I need to get from the difference to the first number? I can't do it because I can't use 34 because that's the 5th term, not the first term. So to get from 4 to 18, all I need to do here is add 14. So the nth term is going to be 4n plus 14. Now from this, what I can then do is now answer the question I've got. So this is kind of, although it's not told me to find the first term, it's not told me to find the nth term, these are all the things that I have to do to get to the answer of the question that they're actually asking. So in order to find the 102nd term, what's going to make your life easier? Well, if I knew the nth term. If I'm not given the nth term, how do I find the nth term? Well, that's easy if I know what the first 5 terms are, or at least the first couple of terms are going to be. So going back to this, so we then need to do is substitute 102 into our nth term. So I've got 4 times 102, add 14. So I've got 4 times 102 plus 14 gives me an answer of 422, and there is our answer to this question. And so the next question we then look at is, does the number 98 appear in the sequence 6, starting 6, 14, 22, 30? You must show you're working out. Now typically, if you're really struggling with and not recognising that this is a sort of a sequences question, and also recognising that this is a linear sequence, so here I'm going up by plus 8, is thinking, well, let's just continue the sequence. I'm just going to keep adding 8 until I get to the number of 89, which in some cases is not too bad. But what happens if that was 198 or 1098? Are you going to be expected to then continue the sequence until you eventually get to that number? Now, no one's expecting you to do that, but it could be one fail-safe way of getting the answer to this question. But what they're actually asking you to try and nudge you into doing is for you to find the nth term and then use the nth term to answer this question. So find the nth term of this sequence, which we know is going to be linear because the numbers are going up by the same number. So here I've got 8n. What do I need to do from 8n to 8 to 6? I need to take away 2. So the formula, or the nth term of this particular sequence, is 8n minus 2. Now I've not finished the question because the question is asking me to see if 98 appears in this. So if I make the nth term equal to the number, what this will tell me is what pattern number does n become. Now when you're doing this technique is, if the answer is a whole number, then yes, it does. And the reason for that is because n is the pattern number. It's like the place of the value of the term. So, and you can't have decimal places. So you can't, in a race, you can't come, let's say, 1.67 in a race, because it doesn't quite make sense. If it's a decimal number, so if the answer is a decimal, then no, it doesn't. There we go, just forgot to add that word onto the end of that. So that's the kind of notes that you kind of need to know. So if we go about going through this, so I've got to add 2, so I get 8n equals 100, and then I've got to divide by 8, so I've got n equals 100 divided by 8, which gives me 12.5. So the answer is no, 98 does not appear in this sequence. And again, do you have to write this down? Could you just write no? Well, again, sometimes a question might have something that looks like this, and it might say show your working, in which all you need to do now, if you just ticked one of those boxes and didn't show the correct working, even if you did tick the right box of no, you wouldn't get any marks, because your working has to be correct in order for you to get the marks. You can't just simply get a mark for ticking the right box. It doesn't work that way, because they don't want you to guess answers, particularly for these questions, and particularly also because it says show your working.